good afternoon, and good evening to everyone. Welcome to our next Groundbreakers episode. Today we have a very special guest, Peter Scott, all the way from Australia. So, with over 20 years of field and executive experience, Peter today is going to bring experience from some of the world's largest infrastructure projects, specifically in the field of instrumentation and monitoring. He's currently the managing director at Osprey Measurements, which is doing really cool instrumentation stuff, which he's also going to talk about soon. And today we're going to explore how technologies are evolving to meet modern infrastructure challenges and what's next. So, Peter, thank you so much for being here. It's a pleasure to have you on board with us.
Well, it's a real privilege to be here, Rick. Thanks for having me along, and to see you as always.
Thank you, Peter. And I think Peter and I've been talking for about a year on various things, whether it's technology, whether it's sensors, whether it's software, whether it's loggers. And I think there's so much today in the industry, and you've been the cornerstone of the industry for about 2 decades. So let's go back in time. Can you take us back to what first drew you to this field?
That's a very generous sentiment, Rick. Vic, thank you. But yeah, well, I suppose probably like you, starting at a very early age. My dad was running ITM back when I was a teenager, and so school holidays were occupied in containers, shipping containers, sorting through old lengths of cable that have been pulled out of sight, or cutting lengths of aluminium beams to install in tunnels. And then, as I got old enough to work on site, I was in tunnels doing night shifts, or installing inclinometers in my school breaks. So, as a 16-year-old, that was really exciting to go in these fantastic projects, like a channel tunnel rail link, nation building projects. And you're there and involved, and you're there from the beginning and all the way through to sort of see that construction process happen. So yeah, it was very enticing, that's for sure.
Yeah.
So that's then led me to Australia, where I came out to work with Kim Malcolm in getting ITM Soil Australia off the ground, where that's really where I sort of cut my teeth and learned a lot from Kim Malcolm. Of course, a big name in the I&M industry, and someone who was able to instill a lot in regards to project management, sales, business development, contracts, all those things. So yeah, that was a huge development for me career-wise.
Wow. So you started from high school, or before high school, grew up in the business. I think that's a very unique opportunity that very few people get to install inclinometers at the age of 16 while getting all the mentorship and knowledge on how an inclinometer works. And I think that's when you fall in love at a very young age. And over time, yeah, you've done a lot of cool stuff. So I feel like you went to Australia, started ITM, learned a lot of, like you said, project management, sales, etc. And you worked at a couple of firms. And then you went, and now you're at Osprey. So what inspired the creation of Osprey? What gaps were you trying to solve? Because you've been in there since you were 16. What inspired you to start this?
Yeah, well, we've all been on site swearing at the equipment that we've been trying to install and get running. But so I suppose it was somewhat born out of that. It was actually Dan, my brother and co-founder of Osprey Measurement Systems, set up Osprey as part of his doctorate studies at CL. So he created Osprey to sort of have some structure around what he was doing there. But at the same time, he and I would have conversations after another frustrating day on site, for example, where I'd been trying to use manual HPGs, which have a pretty poor track record of operations, but provide really fantastic data. And so, I'd have a conversation with Dan about that, and say, oh, why can't there be this solution? And then we'd sort of bat a few ideas back and forth, uh, and then the next time I'd speak to Dan, he'd say, oh yeah, that thing we discussed, well, I've built something up in the lab, and I think it's going to work. And so, just Dan being Dan, a prototype would emerge out of thin air, and enough of these prototypes on the shelf before we sort of thought, well, let's visualize this. Let's make it go with it. So yeah, that's sort of the Osprey, I suppose, that you see now.
Awesome. And I like that because I think installation is a pain. And whether it's the sensor, whether it's setting up the IoT device or the software, it takes a while. It's not like HubSpot. If you want to plug something in a HubSpot, you just press on store, integrate, and from the back end, it's all married. So yeah, I think it's a very important thing that we do to really make installation easy at the sensor level. And also, if you look at today's world, we don't get that many geotechs who want to go on the field, especially in Latin, especially in India. Like you're working with engineers who aren't from the best universities installing your sensors, and they don't have a degree in instrumentation and monitoring. So I think the easier we make it for them, the easier we enable anyone to install these sensors, the way you can install an Amazon Ring, I think that would really change the access to these instruments from the ground level. Of course, from the top level, the compliance, the construction companies, it's a completely different game. But even this might add a small difference to the industry.
Yeah, 100%. Really, isn't it? Our whole ethos is we want to make instrumentation accessible and sort of just close that gap between information requirement and information availability. And that comes all the way from creating cost-effective monitoring solutions, and that doesn't just mean cheap instruments. Of course, that means instruments that can be installed cost-effectively, rapidly deployed in challenging environments. That means instruments that have that properly designed for the application that they're used in, with the conditions in mind, and having that leading the development of the technology.
Yeah.
But then we can start with the instruments and the sensing technology, but then, as you've said, that's completely useless without the rest of it. So we're working very closely with logging developers to make that process seamless, so that that's easy to do on site, but then also working with the front end developers such as Procure, who can then turn that information or that data into information. And that's the key thing. Without that, the whole process is moot unless we've got that actionable information at the other end.
Mhm.
Then the sensors aren't worth anything. That's the value that we're looking to provide. Working closely with the data logger manufacturers to make that seamless, and then to have have a front end which makes that actionable information. That's the key thing.
Exactly. And I think at every level, like you said, it's very important. Like, cool, we make sensors easy. You make the transmission easy and cost effective. You make the data analysis and visualization easy. But after that, the integration is a challenge. And then how do you make sense of that data? Because another challenge that we're also thinking of is cool, you've solved this part of the puzzle, but which is going to lead into the next question. But if you have a large scale tunneling projects, you could have thousands of sensors, and even over 100 tilt meters right there. Now, is a user, even if they get a beautiful front end, going to click on 100 graphs every day or view their 100 dashboards every day? It's so hard for a person in a control room to do that, which is why we have alerts. But again, when you have an alert, are you going to go back and then figure out why that alert happened? So I think the industry has now reached that place of automation and simplification, but that intelligence is something that if we figure out together, because no one team can figure out and get the community on, like okay, out of these 100 tilt meters, this one has an issue and this one has a change in trend. Go check it out. If we get that level of insight, which will have to be a collaborative effort from the designers, construction companies, instrumentation manufacturers, that would be adding another level of value and making it even easier. But I think hopefully that's the direction the industry also starts to pave in further and further as we go into the world of AI and machine learning.
Yeah, absolutely. It's something that I think we're seeing more and more. Obviously the capabilities of AI, almost on a weekly basis, advancing and changing, and the things that we might have said 6 months ago were limitations are now, part and parcel of the tool that we're using there. So, we're working closely with, Griffith University, for example. They've been developing the really impressive AI model, which is able to, take vast amounts of information, but then be able to use that to pinpoint changes. I think they're primarily focused in slope stability at the moment, but changes in the embankment parameters that then allow them to have a dynamic factor of safety, and I think moving on from the green, orange, red alert systems, having models which allow us to identify the not just the not just whether there's cause for concern, but actually, how is that going to impact the broader structure of the how is that going to change our operations? Where are we going to need to focus our maintenance or remediation if that's necessary? Turning that from just a series of red or green dots into actionable information. That's really where the industry is going, I think, and that's very exciting.
Yeah. Yep, I think that's why we become somewhat into the tech world finally. So coming into projects, right? Like you worked on many challenging projects, starting at 16, installing inclinometers, and especially in Australia, because I haven't had anyone talk about the Australian market on the podcast. So maybe you could talk about some of the biggest challenges when you're scaling instrumentation across these projects in Australia specifically, and you could loop in experience in the UK and globally as well. And also beyond challenges, what makes these markets different from the other ones you've been in?
No, it's a good question. I mean, you talk to customers globally, Ritvik, and know that the challenges that people face tend to be quite global. In fact, the
Yeah.
perspectives and the attitudes on each site are different. But I think one of the core things that people the challenges to large scale monitoring projects is visibility and being able to understand how that program is going to advance, accommodate for all of the inevitable disturbances and disruptions to that, and being able to adapt your team, prep your suppliers, and make sure that you're keeping a relatively lean inventory process and procurement process. And that becomes a real challenge because you don't want to be able to accommodate, 13 sites all occurring at once, where if that's only going to occur for 3 months and then it's all going to die down. If there's a way that we can that we can channel that pipeline into something a bit more consistent, that's crucial, and that takes a lot of visibility. But also, it takes a lot of communication with the contractor, because very often it might be that the time constraints are based on a presupposition of how the instruments are installed, what needs to happen before or after the instruments are installed. And technology is developing, so I think there are now opportunities where we can be installing things ahead of time or even post hoc, that would allow a bit more flexibility to work with the program. And so, like all these things, it comes down to communication. Here in Australia, there's um, yeah, I'm struggling to put my finger on a specific challenge in Australia. Really, if I'm honest. The you know the size of the country, and of course some of these
Hmm.
projects are based incredibly remotely, and so if you're out there and you find that you're short on on a valve or a hydraulic adapter,
Ah.
that can be incredibly challenging. And potentially a 3 day delay to a relatively simple problem. Um, so yeah, that's always been a bit fun, having to drive through the outback to find a some obscure hardware store, hoping to God that they've got exactly what you need, which is probably quite unlikely because it's a 1/4 inch BSP olive or something like that. Yeah, and anyway, so yeah, every problem, every project has its challenges. The key one, of course, is just getting everything lined up and being able to juggle all of the components of that.
So key similarity, I think, across the large scale projects is of course communication. And of course there's local challenges. And you said every project is different. And maybe the requirements in each project is different, whether it's a small scale or large scale project. So when you're developing products, when you're recommending products, how do you strike a balance between standardized processes and customized site solutions?
Yeah, like you say, the industry that we work in it's a bespoke industry. Everything that we're dealing with is it's typically project based, so that means that they're building something that's never been built before, and so the requirements are different. But then, of course, we're also working with natural ground, and so the materials that we're working with are inherently different every single time. So we've tried to make our products as standardized as possible to to both facilitate the manufacturing process, of course, but also to ensure that we can be as responsive to our customers as possible to the things at short notice. Um, so we've sort of had to do a bit of a combination of those two things, wherein we can build and develop, build our product to the absolute last stage required before assembly, and then we've got good liaison and communication with our customers so that we're able to then respond to their custom requirements in a very short time frame. And we've been working really hard to bring that down and make sure that we can be as responsive as possible. We've brought our in-place extensometers are now available in
Hmm.
2 to 3 days as opposed to 2 to 3 weeks. Um,
Wow.
our settlement profiler. It's a challenging build, but the processes that we're implementing and the automation allow us to be very responsive to our customers' requirements. Because as you know, it's absolutely necessary in our industry where very often as we've discussed, the visibility isn't always there, and so the need for things on site can often come at the drop of a pin. So yeah.
Exactly. Like you never know what they're gonna need, or you never know what they're not gonna need. Maybe a
Mm.
day before project, they just change the scope. And it's happened so many times, and you're just like, what? So yeah, so I agree. Like it's very impressive you got it down to 2 to 3 days. And I think being lean in manufacturing and all of these concepts are even for us, like at the larger propellant cardio, we're talking about IoT 4.0, we're talking about lean manufacturing because I guess there was a lot of monitoring, but the automation of data and the advancement of software has really made it easier for people to access. And now instead of having 5 boreholes with manual inclinometers and standpipes or water level indicators, they want to put in each borehole will have 3 piezometers at 3 different levels and an in-place inclinometer system or one of your extension meter systems. And instead of having those portable tilt meters, they want a tilt string today. So I mean, it's become easier, which is why we all have to work in a very different way. Instead of supplying 5 for a project that's manual, 50 that's automated. which is a very interesting change that has happened in the age of computing and IoT, I guess.
Yeah, absolutely. And you know, I think it's great to the extent that that information is then used. And I think, you know, going to what we were discussing earlier, you know, the development in the data management, data processing side of things. Obviously, the AI models can only be as developed or as rigorous as the information that it's getting, and so
Hmm.
therefore having that higher density measuring, you know, higher precision, higher temporal resolution. Um, that then allows the AI models to really create something very actionable, very easily interpretable. Um, and so, yeah, I suppose we see as our part in the process developing systems which are as accessible and deployable as possible, and just sort of grease that path between the information that's needed and the information that's deliverable.
Yeah, I agree with you there because even when we're working with a machine learning AI team, we're looking at models, right? And so one is you build models for every sensor specifically, but then that sensor acts differently in different application and projects. So you have to do all of that data engineering, or you build application-wise models. Now, every dam works differently, and every category of a dam works differently. So the amount of data engineering you have to put into this is on another level. It's not as simple as getting your health data on your Apple Watch. Okay, all humans work differently, but at least we've got so many studies talking about the heartbeat of humans and cholesterol that you can do. But in our industry, like, because it's so like closed and isolated and beyond that, there's not that much online data available. A lot of the projects, like we've been there for 58 years, a lot of our projects, maybe till the 2010s, was all manual. Probably for you as well. The 2010s,
Yeah.
2005, you've all written papers with stacks of files, and to even to scan them, upload them, train them makes it so tough. Like, which is why like we're such a new industry, but we have such a huge opportunity to make infrastructure talk beyond
Mm,
just the points of, because it's the same thing, right? Like this tells the status of me, the sensors tell the status of your asset, especially post-construction. So
mm,
it's like we're living in a maze of data engineering before we even get to the models. And after we do the data engineering, it's the data science part of it, which is also challenging to say, okay, now you've sorted this data and found out what works where. Now, what of this data actually makes sense? Do you need the piezometer frequencies for every month, or do you just need seasonal variability based on the rainfall if you're in a tailing dam, for example? Or do you need the tilt meter readings the averages of the whole string, or do you just need it for point by point at that resolution? What makes sense? And then you plug it into a model, and then you have your model predictability rates. And so it's a lot of crazy, not crazy, but right, a lot of high level engineering to do, which is very interesting because which leads to my next question on your perspective, because there's a challenge on the machine learning side, there's a challenge on the software side, and I know you integrations are very important to you as that for us, like working with all the data logger companies, software companies, opening it up. But what is your approach on open versus closed architectures? And let's not talk architectures because that's simple, but open versus closed development in our industry.
yeah. As I say, you know, the sensors themselves are not doing much good unless we've got that connectivity, unless we've got that front end. And so yeah, we've spent a lot of time this last year working with you know, all the major data logger manufacturers to make sure that getting our information from the ground to the cloud is a seamless process. And then, as you know, we've been working with those front end developers to make sure that the information that's coming in is then easily adapted into actionable information. So yeah, our perspective is this needs to be open. This is this is information that we need to share in order to make that process as smooth as possible.
Mhm. Interesting, yeah. And I think I'm pretty aligned on that too, because the more we integrate, the easier it is for us. And ultimately, um, like we were discussing on one of our calls, it's not about the manufacturer or the because almost all hardware is the same, almost all data loggers in today's market are the same, and almost all software are the same. There's a few bonuses, plus minus, and all of them have their own purpose, but together, like solving that ultimate contractor's need is what we're doing. And of course, each data logger and sensor manufacturer has their different features and different perks, but it's up to the consultants or the people telling them, okay, on this project, you could actually use this manufacturer's product for this part of it and this manufacturer's product for this part of it, which we actually do a lot as a service company. But but the open standards would be very interesting, and not to just favor a manufacturer, of course, but say, okay, for slope stability, these are the type of piezometers you need. These are all the available providers. Go check it out. For to connect these sensors, these are all the data loggers. These are the nodes you could use, or these are the dynamic ones you could use. And then for software, these are the options. If you want to focus on this, go with them. If you want to focus on this, go with them. And I guess, like we discussed, the committees are working on it, but it's an interesting point that will come up as we further and further go on and have new people join the industry. Because for the people who've been there for a long time, it's very easy because it's your day-to-day experience. You know everyone. But for the recently uh, graduated kids or getting into the industry, it's like, wait, I don't even know what a piezometer is because barely
Uh,
any colleges teach you what a piezometer is.
that's right, and it's when I go and speak to large consultancy firms, geotechnical consultancy firms, and to get a bit of a gauge on what people's experience is, I'll ask, who's installed a piezometer, and it's surprising how few of them have ever looked at piezometer data or even know what a piezometer or an inclinometer is. Um, but I think that's changing. The exposure to instrumentation is shifting very much in monitoring's favour. As you said earlier, the rise of automation, it's making access to the data and the value of that data so much more powerful. So yeah, that's exciting to see that change, but it's still sorely. Yeah, it's definitely underrepresented in the university degrees, and something that I think could be has the potential to be developed, and then that would certainly facilitate the use of instrumentation and monitoring data in the real world. At the end of the day, um, we're operating in the field of engineering where there is the largest scope for value add.
Yeah.
My brother Dan was saying the other day that you've got steel, you've got concrete, you understand how that works. Mechanical engineers, structural engineers, they've got a very good understanding of how everything's going to interoperate. And of course, it's not to undermine the challenges within those
Yeah.
fields, but in geotech, we have to design for what we can presume to be a worst case scenario. The ground investigations are pitifully underfunded and typically have, we're working in materials that we don't fully understand. And so we're having to design based on that, put in our factors of safety. And so that's a huge opportunity for us to be able to save a lot of money by integrating, by getting information as we're building from the ground and from the structures, being able to adapt our construction processes based on that. That's the largest opportunity for cost savings and optimization that there is in civil engineering. So the fact that it isn't being thoroughly represented at the university level is a little disappointing, and something I'm hoping will change.
Yep. I agree with you there. And I think the opportunity, like you said, is huge. We don't know how the ground moves. And you don't know how the ground will move where. And literally, like you can also save, like when you're monitoring a diaphragm wall, it's built to a design. If your instrumentation is giving you a lot of good readings, positivity, and this is in layman's terms, I'm not talking any engineering terms, but if you have X limit to your diaphragm wall's maximum capacity, and your monitoring is saying it's going to be okay, then you can also make the size of the diaphragm wall small and monitor it and make sure that it's okay and save so much money on the material for one diaphragm wall. And if you scale that across, it's so much cost. And somewhere I do agree with you. Like if we learn, like everyone learns Python, Flaxes, for example, it's become so popular because everyone uses Flaxes or Rock software at a university level. So they used it when they go out into the world, they know, okay, there's Rock Test, Meters, Flaxes, all these softwares that we need to use. So it's very interesting how like the university still plays such a critical role in the industry, but there is not that much talk about it.
In the undergrad, yeah, you're absolutely right. Yeah, certainly in the postgrad, I've worked with plenty of universities who are conducting some fantastic research into the fields
Yeah.
and really, progressing the industry as a whole, which has been great to see. But
Yeah.
yeah, just need to start
Undergrad's the
banning into
gap.
their
Postgrad
undergrads.
is great. I mean, you see, most of the startups in industry come from postgrad or PhD students today, and that have not
Yeah,
grown into mature companies. But the undergrad gap is still pretty big. Yeah.
yeah,
Okay,
no, I
so
think
let's
you're right.
move forward. So we've discussed Osprey, you discussed a little bit of software, AI, machine learning, integration, challenges, but there's so much in the world in our industry today. So we have softwares, intelligent softwares coming up. We have all these IoTs coming up. We have smart and smarter surveying equipment coming up. We have fiber optics. We have remote sensing through InSAR and hyperspectral imagery coming up. But out of all of these, which technology excites you the most today and why?
Yeah, I mean, you're right. There's a lot of development in a lot of different fields. I think for me, what really excites me is distributed sensing and the ability to get a lot of information um, from single systems. Fiber optics doing some incredible stuff with being able to get some very high precision information out of across huge areas. We've been working with the British Geological Survey in their development of the Prime system, which is using electrical resistivity tomography um, to map in 3D changes in groundwater and groundwater conditions. So you can cover huge areas with relatively basic systems to install and get a mountain of information, which can then, whether we're using that information to determine slope stability or project condition, or whether we're able to use this to identify uh, problematic areas or challenge zones, and then be able to construct our monitoring plan from a much more quantified perspective as opposed to a visual inspection or
Mhm.
of course, which will always have their place, but being able to quantify that, demonstrate why we're placing instrumentation where it is, um, and of course the ongoing monitoring and maintenance of those areas. I think that's very exciting.
Yeah, but I think distributed high precision, high processing is coming up a lot. And even dynamic data is coming up a lot as,
Mm.
sorry, even on bridges, there's a lot of dynamic data requirements today. Like your accelerometers are dynamic, your strain gauges are dynamic, your fiber optics are dynamic. And from going from manual readings to static readings, you're going to dynamic. And dynamic loggers cannot run that much on battery. You need that power supply. They cannot run that much on LoRa. Like, so even I feel like the exciting developments also somewhere going to come in how you combine static and dynamic monitoring and how you work with the cloud versus on-premise. Because that amount of data on the cloud is very, very expensive, but setting up a server room is also very, very, very expensive. So there's going to be a lot of dynamic versus static, cloud versus on-premise again, high-speed dynamic versus wireless again, because you need those Ethernet cables to send that data at high speed or the fiber optic cable. So it's going to be a very, very, it's like an interesting time in the industry as we go forward.
Now, I suppose that's where edge computing comes in, isn't it? Really, is
Yeah.
in being able to condense that data into information
Mhm.
before it's then having to be transmitted and executed and stored, etc., and building up those the costs and complexity of the additional infrastructure, being able to identify what's pertinent information here is absolutely crucial.
Yep, and edge computing, I think, will be like the cloud computing age has come to in our industry. I think 2025 to 2030 will be a lot on edge computing, especially on the data logger manufacturers end. So we've talked now about dynamic data, etc. And we're in a world today where I feel it a lot because I'm a lot in the machine learning edge area where in our industry it's still slow. But if I was working in the AI industry or the software industry, I would be getting disrupted every day because it moves so fast. So how do you, as a leader in your organization, foster that culture of innovation within your team and even across your partners?
I mean, to be honest, I think my challenge is in harnessing the innovation that's occurring with the team. I'm very lucky that we've got, um, you know, if you meet him, you'll know he's one of these people whose
Mhm.
minds work a million miles an hour, and there's ideas springing left, right, and centre. But we've also got a big team of guys who are well, it's a small team, but have got people with a huge amount of of experience, industry specific experience in a range of different capacities. Um, and it's great because we spend a lot of time talking with both all the way from our customers through to asset owners, academia, consultants, trying to understand what each of those requirements are. And as we discuss that, there's just always ideas popping up and different opportunities for us to pursue. So yeah, really the challenge is in sort of funneling that into where we see the biggest opportunities and focusing on those while while capturing the prospective developments and making sure that that's sort of up from time to time, just so we're aware of that ability, the ability to reintegrate those into our plans.
That is exciting. And I think that's the best thing ever. Like when you have so many technologies and you just have to cook in the kitchen, like, and get the best product out. So I guess you have to be the best chefs of technology being built in different industries and bringing it together and applying it in an industry with the various ideas we get. So yeah, awesome. So these are the last two questions of the podcast, but future vision. What's your ideal monitored world, say 10 years from now? And if you had unlimited budget, time, all the resources in the world, what is the one problem that you want to solve in monitoring today?
Okay. So I suppose the idealized monitoring world in 10 years' time or beyond would be as I said earlier, our vision really is a construction industry which is data driven. That the information that it needs from the site is made available, and the sort of the value add that we were discussing earlier, available through geotechnical engineering, is being realised because they have access to that information. And so yeah, that's where we see the industry, and that's what we've been working really hard to just sort of streamline that accessibility to information through more deployable systems, through better measurement techniques, and better integrations right from the ground through to the front end.
Awesome.
Challenges in the industry that I would fix if I had an infinite budget.
The best question.
Well, there was something that piqued my curiosity not so long ago. When we're monitoring displacement, of course, we've got to we either need a mechanical or an optical connection to something to a known fixed point, or a fixed point or a known point. We can measure rotation with a tilt meter, but we still need to connect that mechanically to something which is fixed in order to be able to monitor displacement, otherwise just measuring rotation. And so, trying to get a vertical displacement measurement can be very difficult, because you've either got to go a long way outside of the zone of influence, or you have to go really deep to get nice deep datum, or you need to be able to see the stars and get the, obviously GNSS is an exciting tech as well. But yeah, and then there were some people talking about being able to use radio waves to position things, but I've yet to be convinced on that. But time dilation. I saw these clocks, and they can measure to within a millimeter their proximity to the center of the Earth based on the strength of the gravity, and how that impacts the speed at which two clocks are running. Anyway, that blew my mind. I thought that'd be imagine using the relativity to monitor settlements on a project. I think that'd be quite exciting.
Wow.
But,
that would
I
be
dare
cool.
say the budgets aren't quite there yet.
That'd be cool. Using time as one of the raw values. Because every single Excel in our industry has date and column on the left, but if it comes to the right side, that would be cool. That would be changing everything. Awesome.
You're right though. Yeah, all of a sudden it becomes a variable.
Exactly. It's never been a variable so far. It's been unless you do like the frequency thing, then it doesn't exist, like frequency domain, but in the time domain, it's always the x-axis. Like
Yeah.
So like when you're developing a software in our industry, you just need to tell them x-axis is either depth, time, or frequency. Nothing else really changes on the x-axis, unless you're doing some special stuff. But yeah. So Peter, I think
I'm sure there'll be some surprises in store in our lifetime, Rick.
I hope there is, because I mean that's what we're working for and innovating for, to bring the variables from the left to the right. And if you can do that in any way, it'll be cool. So yeah, I think to conclude the podcast, you've been in this industry for a while. You've talked about a lot of innovation today, experiences, where you see the industry going. But for young professionals who probably, hopefully, get listen to this podcast, who don't have experience in the industry or just walking into this industry, what is like an experience or a piece of advice or anything you would like to offer to them?
It's a good question. I've hired and I've worked with people in this industry from a wide range of backgrounds. Whether they're geotechs or geologists or plumbers or electricians or technicians. There's they're facing this industry for pretty much anyone, and they all contribute to being able to deploy these systems in a reliable and robust way. And so, really, just I think open-mindedness and diversity of skills is the key thing, because if you're deploying instrumentation, then you need to be able to understand. I mean, less so these days, but you don't need to be programming your Campbell scientific loggers anymore. Unfortunately, that was always a bit of fun, having to wire up your systems, and that's all been a bit more streamlined. But there's still powerful tools to be able to understand those electronics, programming, geotechnical, drilling. There's a wide range of skills which all come together, and that's what makes the industry so fascinating, if you ask me. Is that you get to exercise a huge number of interests in a single field. You're never bored.
I think that's a great way to conclude it, because this podcast talked about various interests, various technologies, various experiences. And I think if people just come in with an open mind, like you said, and try, disrupt, think differently, and just put solve problems. And a lot of our problems are simple. We complicate them to a level of high level complexity, like SDI. But
Yeah.
yeah, so I think that's a great way to conclude the podcast. So thank you so much, Peter. It was a pleasure to have you on. Thanks for sharing your experiences, where you're going in the industry, where Osprey is growing, where because you guys have come up with some really cool products, and I think the integration of the sensors with the loggers to the software to ultimately the intelligence is the path we're going on. And hopefully, in that path, we can put time from the x axis to the y axis. So, thank you so much.
Thank you. Thank you for your time, Rick. Great to see you again.
Thank you.